So I'm going to work through the construction of this board, which is the Stepper Hat 3.9. This can actually operate either as a Raspberry Pi add-on board or as a standalone stepper using the ESP32 on the D1 Mini. So I'm just going to go ahead and populate the lower level components, the ones that are closer to the PCB, and I'm going to populate the diode array that's used for clamping the sense inputs. So this is a small surface mount component. There's actually only 2 surface mount components on this board, and this is one of them. It's an optional component, but I'm going to populate it anyway just so that you can see how that's done. This component is really just used if you are operating in an environment where you think that the sense inputs would potentially be driven above 3.3 volts or below 0 volts. So while it looks as though there is a tiny dot on the chip towards the bottom left hand corner as we're looking at it now, so what I like to do when I'm soldering surface mount components is to put a little bit of solder in one of the corners, and so I'm going to choose this corner here, and then move the chip into place with some tweezers, and then just catch that pin and then try and orient the chip appropriately. So I think that's probably okay. And now I'll just go ahead and solder the other pins, probably starting on the other side, so that I have the best chance of not detaching the pin that I've already soldered. So I think I've bridged 2 of the tracks there. I think that's sorted it out again. And then what you can always do is if you do bridge the tracks, if you just use some solder wick, which is this kind of product, then that proves quite useful in removing the bridges on SMD components. I don't think I need to use it in this case. So now we'll move on to the capacitor, the 47 microfarad capacitor, which sits pretty much right next to that component, and just get that one in place. Similar process, get one pad with some solder on it, and then edge the component up to the solder until it sits in place, and then solder the other side. That process normally works for me fairly well, and it allows you to orient the device a few different times while you still have just one pad attached. So I've got a 1/4 watt resistor here. Oh, actually I've got the wrong value of resistor as well. That's a 4K7. I need a 47 ohm, so I'll go ahead and go get the other resistors. Okay, so I think the next thing we should probably do is have a look at which component So if we now have a look at which component we could do next, there is a voltage regulator here which is fairly low to the board. There's a separate resistor here, 47 ohms. That's actually just used for driving an LCD display, the backlight on a display, but I'll populate that anyway. And then there are these resistor arrays here and two down here, which are probably the next ones after that resistor. So let's just get on with that. Here's the resistor. So I'm just going to bend the pins manually. I think I've set this up for a resistor of this general size, so that should work well enough. Okay, so just going to solder that one in place. The pads on the back of this are actually a little bit on the small side. That's worked out okay. Best not to cut the wires on a component too close to the board in case you actually take some of the pad off as you're doing it, but that seems okay. So then actually I've realized there are these two diodes which protect the driver MOSFETs if the load on the FET is going to be inductive. So these are going to go this way. So I think I can just bend them fairly crudely like this. Hopefully that will be approximately the right size. Yeah, that seems okay. So that's one of them in place. And the other. Conversely, these have very large solder pads. So that's got those. Okay, so now we'll move on to the resistor arrays. So these have a kind of identification of pin 1 with dot here, and that's this square area here. So we'll put those in place. They're all 10K bust arrays, which basically means there are 4 resistors with one common end, and that common end is the pin 1, which is marked. So I'll just hold those while I turn the board over. So what I'm now going to do is tack one end of each one, so they're not actually in a very good orientation, they're just lying against my soldering mat, so they're all at sort of strange angles on the other side. Kind of, we can see that here. So I'm just going to now, having done one pin, I'm just going to hold them with my finger underneath, and then I'm going to just move them into a more vertical orientation while I melt the solder on the reverse of the board, just to get them into the right place. So now they look a bit more upright, and then I'll just solder those into position. Okay, so that's pretty much it for those. So just click the spare leads off the back. That's that done. Right, so those are reasonably short. So now we're going to put the regulator in place, this low regulator here. Look at it, it has pins that are formed to a much wider angle than the pin spacing that I've got on the PCB here. So it looks as though I'm going to have to clip these quite close to the chip around here in order to be able to get this chip into the board. So I'll go ahead and do that. And now let's see if they're still slightly splayed. So I'm just wondering how easy it's going to be to get these in there. Don't want to make them too short because then they might not even go all the way through the PCB. Yeah, it's proving a little difficult to get that in. So I think I'm going to have to try and straighten up the pins. It just seems that there's a tiny lip on it now, which hopefully I'll be able to clear up. So I don't know if you can see that, but I think now I've managed to get them a bit straighter. Hopefully that's enough. Okay, that seems to be enough to get it into the PCB. So now I think I'm going to put in place the IC socket for the 74HC138 328 line decoder, which sits here. Now it looks as though that's a little bit close to that resistor. That probably should have been an 1/8 watt resistor. It looks like I can just about get that in there. So yeah, and also it's not quite done this in quite the right order. I think this is a bit lower to the board than the resistor arrays and maybe that regulator that we just put in place. But anyway, I'm just going to tack one of the pins and then I'll try to hold the chip in place, avoiding the pin that I'm going to actually melt the other end, the solder on the other end of, and then I'll just push it into place so that it sits firmly to the PCB. And sometimes you end up having to do both ends. This one's not really moving, so that looks okay, but you have to do pins at both corners just to make sure that you've fully got the PCB in place. Sorry, the IC in place. So let's just solder all those. Now there's a few jumpers that you can see on the bottom of the board here, and if I just turn that round, hopefully you can read what these say. So these are to do with options in terms of pins. So in each case, one or other of these pairs of jumper pins would generally be connected if you wanted to use this functionality of the board. So this is for a SPI display, and picking which pin is going to be used for the chip select, actually the SPI chip select on that display. And this is the touch pad if you're using a touch pad. And then here there's the PWM for servo 2, so the control signal for servo 2, which you can either choose to be on 22, GPIO 22 or GPIO 17. I think for now I'm just going to connect. GPIO 17 is also used for the display, so these are kind of options. I think for now I'm not going to connect any of them. This board I'm not really going to use a display with, I don't think, and I'm certainly not going to use a second servo, so I think I'll just leave that unconnected for now. Okay, so now let's look whether there's anything else that's lower than the headers. So there's a whole set of headers that are going to go in place in positions like this, and then we've got also various header strip that's going to go potentially along. This is the one actually for the display here, but we can sort of see these are approximately the same height as each other, so there's not really much to be done in terms of choosing which of those to do first. So let's just have a quick look. Then there's also the power connector, so that's going to be going here. That's probably a bit higher than these once those are in place. So yeah, so well, let's do that last. And then finally, I think I've got, okay, sorry, so these are all jumpers around here, and then I have these connectors. I have a regulator chip which is going to go in here, so that's like a DC to DC converter, so that's pretty high. And I've got these connectors which I'm going to use for the servos, so you can use different kinds of connectors on this board. You could just use header strip like this to connect the servos, which is commonly done in 3D printing, ramps boards and so on, but I'm going to use these slightly more secure headers, connectors rather. Okay, so I'm going to put these connectors in place. Okay, just about managed to hold those in place while I turn the board over. And then just solder those. So so therefore we've got the 3 stepper motor connectors in place. Now I'm not actually going to populate the back this connector, which is would be for a Raspberry Pi. In my application I'm not going to use a Raspberry Pi, but that's where it would go. I'm also I may actually populate that SD card holder. So let's now move over to the other side and start populating some of the header strips. So I'm just going to break up some of these headers. I don't think I've got ones of, oh actually those are the ones for the stepper motor drivers. So here we've got a header that needs a 2-pin, so I'm just going to break a 2-pin off. I got a 3-pin by mistake, so let's just put that over here. And then I need just do these as 4s. Okay, so I think I just need a couple more 2-pin. So let's see, that's another 3 there. We can go there. Now these, actually looking at it, these are actually underneath the, this is underneath the one of the stepper drivers, and you can just about put a low header under one of these drivers, but actually I think it's probably more logical in this case just to connect those with wires. These are actually both to do with the Raspberry Pi. That one selects whether the this board, the hat, powers the Pi, and since I'm not using a Pi, I don't need to populate that one. And this selects which pins are used for connecting the serial connection, so that the Pi can communicate with the ESP32. So again, I'm not using a Pi, so I don't need that one. So I won't populate any of those. So then we just have these 2 positions down here for FETs. And I think I will populate the display connector here, and then we just have that one, and it looks as though that's everything now, all of the male headers on this PCB. So I'm just going to use a different PCB here. I'm going to put it over the top to hold everything in place while I spin the board over. It's a little wobbly there, I'm not quite sure what I've done. Something's obviously higher than other things, but what I'm going to do is now just tack those in place. These are actually, some of them are not really at the right height at all, so I don't know, it seems a bit, but I'll just try and tack every one pin on every connector if I can work out which they are. So that's those 2. I've done that one, I've done this one. There's a couple over here which are actually only very slightly through the board, but they're holding in place, so that's okay. There's a single pin there which I haven't actually done yet. Those are the ones that I mentioned, which are to do with the Raspberry Pi. So I think, is that all of them? Not sure, something's probably going to fall out. Yes, it did. So one of the 3-pin ones I missed. So that was that one there. So again, I'm going to try and tack one, and it's now become quite tricky. I think what I'll do now is I'll put these in place more firmly. So let's just, looking at this one for instance, get that one in place. this one. That connector seems to have worked okay. The long one there, it's reasonably vertical. And then this one, just work out which pin is the one I'm going to heat up so I don't burn myself. So that's that one. And then these four, those are all reasonably well in place already, I think. So that, there's a 3 pin in there that's not really quite right. So now it's just these two here, which are a bit wonky. So that looks better, but not quite perfect. Let's see if I can improve on those two. Okay, I'm happy with that now. Almost happy. It could just be better. Slightly better. Right. Now, this one is a bit problematic. I could do the same thing, just put the PCB on the top. But another thing I could do is just put a header over the whole lot like this, so it's held in place by the one that I've already got soldered in, and then it just makes life a lot easier. So there we are, that's got one end of that one. I can just check that it's in a good place before finalising all of them. So right, we'll just finish off all of these now. Okay, so I think now we're on to the female headers. So there's a set of female headers for the stepper motor drivers, and there's also the female headers for the ESP32 module. So I think I'll do the ESP32 ones first. So that's one of those. And there's the other. Let's just put those in place. Same thing, one end first. Snap it into place. And then the other one. They seem fairly secure at the other end, so I don't think I'm going to need to do both ends like that. Let me just check. It's probably quite a good idea to get these nicely seated, so I will do that actually after all. They haven't really moved, so that's fine. Get these pins soldered. Okay, so once I've done these, I just have to do the I hit that pin there, which was unnecessary. So that's actually a spare pin. So the main difference with this board versus previous ones in this series of stepper motor drivers is that this one has the display capability for a touchscreen display, which I've been looking at using in a 3D scanner that I'm working on. And it's also got a third stepper carrier, which some of the previous ones that I've built didn't actually have. So I think I've got all of those. Oh, there's some of the male headers that I forgot to solder over here. So let's just catch those. So let's have a look. Done all of those. Yeah, so I think I've done everything that I've. Oh no, I'm wrong. These haven't been soldered. Right. So now I think I've got all of them. Okay. So now we go on to the stepper motor carriers. So let's see. We need a few of these. Female. Okay. Right, so that's all of those. I'll just use this approach again to get the board turned over. And then, as always, I'm just going to catch one end of each of these. So I think what I'll do now is I'll actually put the stepper motor driver modules in place. So I'm going to actually put the stepper motor driver modules in place. These are just some random ones which don't have heat sinks on them, or actually one of them does, I've just noticed. I'm just putting them in any old orientation. This is not how they're supposed to go, but just to hold all the pins into place while I do the soldering. So I've actually found that I'm running out of solder, weirdly enough. I haven't bought solder for a really long time. So, when I came to buy some more, it seems that the solder that I've been using has a really tiny amount of lead in it. It's a multi-core SN62 solder, which I didn't think had lead in it, but anyway, apparently it does. according to a supplier that says that I can't buy it anymore. So I'm just going to have to change the solder I use, which I've no idea whether that's going to influence anything in terms of my satisfaction with the joints that I make. But I've ordered some, I think it's SN64, I can't quite remember exactly what it is, but we'll have to see how that behaves compared to this, which I've always really liked. Okay, so I think we just have now, take these out. I'll try and take them out. So we just have this component, which is the DC to DC converter. It's going to go in there. So these tend to be a bit wobbly in there, I found anyway. Maybe this one doesn't seem too bad, but for some reason the pins seem to wobble a little. They maybe don't, because it's a potted module, they maybe don't come right down the sort of meniscus on the potting compound. It means that they're not really directly in connection with the board, so the module tends to wobble a bit, but this one actually seems a lot more secure than normal. And then put that socket in place. This is so I've designed the board so that there's the potential to put in either this size of socket or a much smaller one for which I tend to like to use for 5-volt purposes. And if you want to power this board from 5 volts, underneath this chip that I just put in, this DC to DC converter I just put in place, there's actually a jumper. So this DC to DC converter doesn't work with an input voltage of just 5 volts. It has to be about 7 volts minimum. And then it regulates down to 5 volts. So if you are actually just powering the board from 5 volts, then it's necessary to not use this module. There's a jumper underneath which you can just connect, and then I tend to want to use a smaller connector here so I don't inadvertently connect 12 volts. So that's why there's this arrangement here which allows for a much smaller DC barrel connector to be used. So that's going to go in now. Since this is also the kind of mechanical connection for the connector, it's probably worth putting a fair amount of solder on here just to make sure that it's reasonably done. Sometimes I bend if I think it's going to have a fair amount of stress on the connector, I bend some of these pins on the connector down just to try and give it a bit more structural stability, but I mean it's pretty good, I think. Okay, so I think we're more or less there now. These pins all down here are for expansion, so I'm not going to populate those. These are just spare holes as well, so again I'm not going to populate those. We've already talked about these are for expansion, and this is for the Raspberry Pi connection, which I'm not going to use. So I think that is pretty much it. There's one pin down here which is a ground test point, so you can put a single pin header in that position, and I think I will do that because I quite like having test points on boards. So let's just see if we can get that to stay in place while I solder it. Single pin headers are particularly difficult to get vertical, but I'll just try to do it by wiggling the board around against my soldering mat, and I think that's good enough. Okay, so let's just finish off the construction now by populating the chips that haven't been put in place. So we have the ESP32 module and 74HC138, and then we have the two stepper driver modules, which these are actually FY-SET-C silent. Actually, these are 2100 modules. I think I'm going to be using 2130 modules on this board, so I'll find a couple of those, but I'll just put these in place to show you where they go and the orientation. They look very similar, the other modules. So let's get this out to start off with. So we're actually going to not use these female headers, we're going to use male headers on the board. Okay, so I'm actually going to do this by, I haven't actually got 2x10 male header strips, so I'm just going to take 1x10 and then, oh, it didn't work. I'm going to put them in place in these into the socket that they're ultimately going to go into. So let me just try and fix this one. You can see I've managed to push these 3 pins in a bit too far here, so I'm just going to pull those out again. Okay, that looks about right. And then I'm just going to use that as a sort of template for this. So this goes on this way round. Doesn't really matter at the moment unless I was to leave it in place, but that is the correct orientation for it, so that the USB connector is above the power. Okay, so that's how it's going to ultimately sit. So I'll just solder those in place. Some of these D1 Mini, they seem to be, I'm not exactly sure who originally manufactured them. There's a company called WeMos, I think, or a brand WeMos, which seems to be associated with them, but whether that's actually the origination of them or not, I don't know. But some of them have varying different 3-volt regulators on board, and I have found that some of them from certain brands seem to have very weak regulators, and so I've decided not to use the 3-volt output from the carrier for any other purpose, which is why there's a second 3-volt regulator on the main PCB. But also I have noticed in some cases they, even just powering the ESP32 itself, seems to every now and again give a warning of low power brownout detection. So it's probably something to look out for in terms of the brand of module that you buy. Okay, so that's those. And then we just have, so I have to take that out now because I haven't populated the 74HC138, which goes underneath it, so that goes in here. Now we're just going to bend the pins, so I'm just going to, they're generally splayed outwards on a chip like this, so I'm just going to roll it slightly forwards to straighten the pins up. So you can see they're reasonably straight now, and then pop that in place, making sure I get it the right way round. So that goes with the notch upwards. This will be pin 1 in this position. And push this back on. So that's that one, and then finally 2 modules. So the orientation of these, you can just check on the base of the board. So the I think 2 of the pads actually have square pads. I think it's hard to see, but I think this one and this one are square, and those are for the ground connections, of which there are 2 at this position and this position on the carrier. So that would go in that way round. So basically like this. And I'm actually just going to use 2 of these in this project, so I'm just going to populate these 2, which are carriers 1 and 2. Okay, so that completes the construction.